Hi, welcome to Math 230 Discrete Math at Coastline College. My name is hao-nhien and I'll be your professor. Quickly, what this course is about. It's about the fundamental math of several fields, including computer science, game theory, and economics. This class is also more abstract than many math courses that you may have taken in the following sense. In an algebra or calculus class, for example, typically you deal with numbers and functions of numbers. In discrete math, we manipulate structures because that's what computer scientists, game theorists, and economists do. Computer scientists, for example, can define functions of data types, not just functions of numbers. They can design blockchains to validate Bitcoin transactions. Those are structural manipulations. This course will also require more rigor and precision. For some of you, chances are this course will be the first time you need to do proofs. It may sound scary now, but we'll build your ability to prove things slowly. So by the end of this class, you'll be telling yourself, like, why was I ever worried about proofs? It's just my intuition put down on paper in an organized and mathematical manner. This course is called Discrete Math because it's about discrete structures, structures that have elements that are separate from one another. The first one, we call it a graph. It's discrete because each vertex, each dot, is separate from the others. And it's structured in the sense that there are these edges built around the vertices, and each edge has rules that go with it. So for example, if you look at vertex C, you see there are three edges coming out of it, and they only come out of it. There's nothing coming in. That's part of the structure. The second picture is a logical circuit, which you will learn about in this class. And it's an abstraction of a computer circuit with actual chips and wiring. And the last structure in this example is a set of bits 0 and 1. It's a discrete set, and the structure consists of computations that we define on it. In fact, this is a good illustration of abstract math because we can take a set of two numbers and just up and define computation on it. The opposite of discrete is continuous. So for example, calculus is continuous. The top picture of a solid of revolution is a continuous surface in the XYZ space. The bottom picture of the graph of a rose is a continuous line on the XY plane. And the XY plane itself is a continuous surface. We don't do any of that. This course counts as an advanced math course. I'll be helping you tighten up your mathematical arguments, where you will learn to use precise language and prove things. When you prove things, they are mathematically true for all eternity. Here's a rough outline of some of the things we'll learn in this class. Mathematical logic and Boolean algebra, methods of proof, number theory. When people say number theory, they mean mostly integers and things related to integers. That's why it's discrete. Set theory, mathematical relations such as functions. We'll learn to define functions more abstractly so they can be applied to more than just real numbers or complex numbers. Counting, and one application of counting is discrete probability. And graph theory, we'll learn structures such as graphs and trees. In biology, gene sequencing is an application of graph theory. Some of the applications that you will see in this class are logical circuits, prime numbers and divisibility, which then leads to cryptography, algorithm design, game theory, optimization, and that's just a sample. So I trust that you will enjoy this class. Again, welcome.